Hello everyone, today we're talking about transformations of polynomial functions. So we can transform graphs of polynomial functions in the same way we transformed linear, absolute value, and quadratic functions. The first type of transformation that we can have is a horizontal translation, and this shifts the graph left or right. In our function notation, that's going to look like f of x minus h. Remember when this says when h is negative in here, that means it's going to the right. If it's a plus h, then it's going to the left. So for example, g of x is equal to x minus 5 to the fourth. This would shift the graph 5 units right. From the parent function, f of x is equal to x to the fourth, which is what all of these are transforming from. And then x plus 1 to the fourth would be 1 unit left. So what you see in there is going to be kind of opposite of what you think. If you see a minus a number, that means it's going to the right. If it's a plus a number, that means going to the left. Then we also see a vertical translation, and that shifts the graph up or down. And so in function notation, that's going to look like f of x plus k. So again, with f of x equaling x to the fourth, we could have x to the fourth plus 2, which would mean the graph goes 2 units up. Or we could have x to the fourth minus 7, which means this graph is going 7 units down. And then we also have reflection, and so we have two different types of reflection we have. We can either have a reflection over the x-axis or a reflection over the y-axis. If we were doing a reflection over the y-axis, this would look like f of negative x. So this is the y-axis. So for example, I could have negative x all raised to the fourth power, which is just equal to x to the fourth. And this would be a reflection over the y-axis. Or I could have negative f of x, and this would be a reflection over the x-axis. So for example, g of x is equal to negative x to the fourth. This would be a reflection over the x-axis. And then I have horizontal stretch or shrink. And this is when the graph stretches away from or shrinks toward the y-axis. So this in function notation looks like f of a of x. And here, remember, if a is greater than 1, then this is going to be a shrink. If a is less than 1, then it's going to, or between 0 and 1, then it's going to be a stretch. So for example, I can have g of x is equal to 2x raised to the fourth power. Since a here is 2, which is bigger than 1, this is going to be a shrink. And it's going to be a shrink by a factor of 1/2. So you do the reciprocal of what you see in here. Where on the flip side, if I had g of x is equal to 1/2 x raised to the fourth power, here the a is 1/2, which is between 0 and 1, so that means this one's a stretch by a factor of 2. So again, we flip our a. And then we have a vertical stretch or shrink, and this graph stretches away from or shrinks toward the x-axis. So this is going to be opposite from the horizontal. Here, if a is greater than 1, then it's going to be a stretch. And if a is between 0 and 1, then it's going to be a shrink. So for example, I could have 8x to the fourth. That would be a stretch by a factor of 8. Or I could have 2/3 x to the fourth. Here, my a is between 0 and 1, so that means this is going to be a shrink by a factor of 2/3.